All right, welcome back. So now we're going to be looking at what happens if we have a binomial at the top as our numerator. So let's have a look at how that changes things. So looking at the first one here, we have x plus 1 all over 2 plus x plus 2 all over 3. Now the same idea applies as before. We're still going to look for a common multiple, and the lowest common multiple between these two is going to be 6. And with that, we kind of now need to get to the part here that's a little bit different. So obviously, to go from our 3 to our 6, we've multiplied it by 2, which means I have to do the exact same to this group up here. We're also going to multiply that by 2, which means we're going to write this as 2 and then bracket x plus 2. That's just how we're going to leave it for now. We'll expand this later and then we'll simplify. And let's do the same to this one. How have I gone from 2 all the way to 6? Well, I've multiplied it by 3, which means I have to do the same to this entire group here. Which means once I've got that done, it's going to be 3 times x plus 1. Okay? Now, because these are now the same denominator, we put the whole thing over 6, and we start to think about expanding these. When we have expanding brackets, we're multiplying the first coefficient into each term. So 3 times x and then 3 times positive 1. 3 times x is 3x, and 3 times 1 is positive 3. 2 times x is 2x, and then 2 times 2 is positive 4. Once that's done, we're going to collect our like terms. And to collect our like terms, we're looking for the ones with either the same pair of exact polynomials, or we're looking for ones which have a constant value, just a number without the polynomials. So 3x and 2x is going to be 5x, and then 3 plus 4 is 7, all over 6. And that's our answer, and we're done. So it's the same idea as the last one. It's just that we have to add this extra step where we expand and collect. Down here, we're still going to look for any way we can simplify. All right. Question 2. 2x minus 1 all over 5 plus 2x plus 3 all over 4. Now, what's the common multiple here? The lowest common multiple is going to be 20, and you can list them out if you want. I did this before. You can always write out all the multiples. And the lowest point where they both have the same value is going to be our target for our lowest common multiple. But obviously, at a certain point, you don't want to do that. Right, now I know I've taken my 4 and I've multiplied it by 5, so to get to the second term, so I'm going to do the same thing to the top. And I know to get this 5 here to be this 20, I've multiplied it by 4. So I'm going to do the same to the top values. Right, now we're on the next step. We're just going to expand both of these. 4 times 2x is 8x. 4 times negative 1 is minus 4. Plus 5 times 2x, which is 10x. And then 5 times 3, which is 15. All over the exact same denominator, which is 20. Now, collecting like terms is the same every time. We're just looking for our constant values, or we're looking for ones with exactly the same polynomials. Okay, we're looking for either of those situations. So 8x plus 10x is 18x, and minus 4 plus our 5, our 15, is going to be 11. right? And that's all going to be over 20. And there's nothing there we can do. We can't make that any more simple. We can't simplify it any further. That's our answer. Or our third one, x plus 3 over 6 plus x minus 3 over 12. Now this is a perfect example of where we want to be a little bit lazy if we can help it. This whole term can stay exactly the same as long as I put both of them over 12, which is a common multiple between them. So I should leave this one entirely alone. It means I don't have to do anything. I just have to worry about the first term here. We've gone 6 to 12, which is multiplied by 2. Do the exact same to the top, 2 times x plus 3. And we're already ready to expand. So any opportunity you have to really just leave one whole fraction the way it is, we'll take that one. Right, so now we're going to be looking at expanding. So 2 times x plus 3 is 2x plus 6. And then we just leave the rest as is, plus x minus 3 all over 12. In this one, we now are going to do our like terms. So we have 2x, then we have x, and we have our positive 6 and our negative 3. Alright, so using that information, 2x plus x is 3x, and 6 minus 3 is positive 3 all over 12. And you might look at this and think, that looks like it can be simplified, and you would be correct. Now, the first thing we want to do whenever we're simplifying an algebraic fraction or a one with a binomial as its numerator is take out a common factor and factor it. So we know that the common factor in the numerator is 3, and we can factor out that by running as 3x plus 1. Still the same thing, if I expanded this, it will end up with 3x plus 3 all over 12. And now that we have these as essentially two multiplying factors, we can divide both the top and the bottom by a common factor between the 3 and the 12. So if I divide the top by 3, I get 1, and the bottom by 3, I get 4. And this ends up with 1 times x plus 1 is just x plus 1 all over 4. And we've made a very complex starting point look much more simple. All right, the fourth one. Okay, again, looking at that common factor, the lowest common multiple between them is going to be 6. We need to change both of them because there's no one we can just leave the same. Now, there's a couple of ways of doing our negative fractions, and we'll get into them. But first up, let's decide what's happened to this. To go to 3 to 6, we multiplied it by 2. So it becomes 2x plus 3. And to go from 2 to 6, we multiplied by 3. So we have to do the same thing to the numerator. Okay, expand, and then we will simplify. So we got 3 times x, which is 3x. And 3 times positive 2, which is positive 6. Minus, and we'll put the result of this into brackets just so we get our sign consistent. 2 times x, which is 2x, plus 2 times 3, which is 6. Now imagine whenever we have a negative outside a bracket like this, there's actually a hidden 1. And this hidden 1 means that what we are doing is we're going to apply the negative 1 and distribute it just like we would with expanded. You do not have to do this. The only reason I do this is just so we make sure we're getting consistent signs at the start. And again, this is all over 6. So we end up with 3x plus 6 minus 1 times 2x is minus 2x. And minus 1 times 6 is minus 6. Now we have our signs effectively apply consistently, and we can look at simplifying or collecting our like terms and then simplifying. So Like terms here, 3x and negative 2x, and our positive 6 and our negative 6. So we know, basically, because we have positive 6 and negative 6, they're going to cancel each other out. And then we'll end up with 3x minus 2x, which is just x, over 6. Alright, and that's our answer, and it's a lot simpler and easy to work with, and we just have to make sure that at this step here, we just need to get our signs correct. It is very common for students or people just in general to apply the negative sign to only one term and then leave off the rest. Okay, next one. We have 2x plus 1 all over 4 minus 2x minus 3 all over 5. Now we're going to look for a common multiple, and the lowest common one between them is going to be 20. Right, so now that we've done that, we can apply basically what we've done to each one. So we know that we've multiplied the end term, the end fraction by 4. So we'll apply that to the same part on the numerator. If you're asking why I'm doing the last fraction first, I have no idea. I just ended up doing this this way every single time. But it doesn't really matter. It's just up to you how you would approach it. Just have a process and be consistent. Right, next one we're going to look at now is expanding. So we've got 5 times 2x, which is 10x, plus 5, minus, put everything in brackets, 4 times 2x is 8x, and 4 times negative 3 is minus 12, all over 20. So the first part stays exactly the same, and then we apply this negative 1 essentially across. Negative 1 times 8x is minus 8x, and negative 1 times negative 12 is plus 12. Because a negative times a negative is a positive. Okay, like terms, we have a couple. We have our 10x, and we have our minus 8x, and we have our positive 5, and we have our positive 12. So now that we've done that, we can in fact use that information to collect them. So 10x and negative 8x is going to be 2x, and then 5 plus 12 is 17 all over 20, and there's nothing else we can do there, so that's as simple as it's going to get. Okay, moving on. This is our last one. 2x minus 1 over 3 minus 2x plus 1 over 6. We are going to keep this last term because I don't want to do any extra math. I'm being lazy. So we're going to put it all over 6 as our lowest common multiple. Now, just one thing. You can pause these at any time to practice, and later on I will put up some lessons that go with these videos that you should just be able to do online. I have some of those already on the channel. They're in a link down below, but I'll be putting more of them together very shortly to go with the rest of these lessons. Okay, we have multiplied this first fraction by 2, so we have to do the same thing here. And then once we're done, we're going to expand. So 2 times 2x is 4x, and 2 times negative 1 is negative 2. Minus, keep everything in brackets. Well, we don't have to for this one, but you can. You can do it again if you would like to. If you're not getting it, I encourage you to keep doing it. Right? It's a little bit of extra writing, but if you really aren't following without doing it, then you should totally draw all these things in. Minus 1 times 2x is negative 2x, and minus 1 times 1 is minus 1 all over 6. Add our, collect our like terms rather, and we have our constant values. And now that we've identified our like terms, let's collect them. So 4x minus 2x is 2x. And negative 2 minus 1 is minus 3, all over 6. And that's our final answer. So I hope this is helpful, and I will see you in the next one. Thank you. Bye.